So what have we learned since 1906? Because the data had been so carefully documented from the 1906 earthquake, researchers are still using this data today to learn more about that earthquake. This is an example from one of the researchers in our office in Menlo Park at the USGS. He re-looked at the surveying data and actually found some additional data, reanalyzed it with modern techniques, and he was able to come up with what we call a slip distribution. That is how much the fault slipped at different points from the southern to the northern end, and they're shown where he could analyze it with the green bars. And you can see at the northern end and also down near Point Reyes, we had slips of as much as 25 feet. So if we're standing on either side of the fault, at the time of the earthquake, we're going to get shifted 25 feet laterally, and that's what happened there. And in the gray balls show the actual measurements that they made of the surface from fences and roads and things, and you can see there's a pretty good correspondence. The main thing that came out of this, it showed that the earthquake not only ruptured 200 miles on land, but it extended offshore, total distance of about 300 miles. We've also resolved where the earthquake began. Had always been a lot of debate in different locations, but this is San Francisco here, and it began just offshore. This is sort of the range of uncertainty because the measurements weren't very precise. It began about 6 miles deep. We've also learned that there's not only the San Andreas Fault and the Hayward Fault that had the earthquake in 1868, but we have a whole network of parallel faults in the Bay Area that are accommodating plate tectonics, the motion between the Pacific Plate and the North American Plate. And by measuring seismicity today, we can see some of those faults are locked, meaning, like the San Andreas, essentially no earthquakes on it. Although some of the faults in the East Bay are creeping, they're moving at the upper portions all the time, offsetting sidewalks, people's foundations, that sort of thing. Probably one of the most significant things that we've learned is that we can actually measure this deformation that's occurring across the Bay Area, what we would call strain accumulation, how this rubber sheet that is the Earth's crust is getting loaded, and all the faults in it are getting loaded. These are measurements where we now use GPS receivers collecting data continuously. And what you're seeing here relative to a stable North America, you can see as you move out toward the Pacific Plate, the displacement continues. And this is what loads all the faults. And if we look at a station in the gold country in the Sierra Nevada compared with an island offshore from San Francisco, this is a plot of the relative position of these 2 points. This point is moving to the northwest relative to that, and you can see this is measured over about 4 years, a rate of about 1.6 inches a year. There were no earthquakes in that time period. This is the ongoing deformation. At depth, the rocks are flowing, and they're just causing this shearing. The most exciting thing for us as scientists is that you can actually measure that deformation in just a matter of a few months, and the rate that you get is the same as the million-year rate we know from geology.